Theme: Autonomous Scientific Discovery, Week 24, 2026, Target Length, 500 words, 2.5 minute, Tone: wide-eyed, grounded, forward-looking == host. For years, we've heard that AI would accelerate scientific discovery. But what that usually meant was AI helps a human read more papers. AI helps a human design one experiment. AI helps a human write up the results. This week, that story changed. A cluster of papers hit the R14 that collectively describe something new: AI systems that don't just assist science, they do it. From reading papers to writing code to physically handling lab equipment, the loop is closing. Host. Let's start with EurekAgent. This team reframed autonomous discovery as an environment engineering problem. Instead of designing better agent prompts, they designed better agent environments, permissions that prevent runaway execution, GIT-based artifact management, budget constraints that make the agent cost-aware, and easy human override points. The result? New state-of-the-art solutions in math and kernel engineering, including a 26-circle packing result discovered for under $11 in API costs. That's not a demo, that's a laboratory economy. Then there's Agents K1, which process 2.46 million scientific papers into knowledge graphs rich with entities, claims, evidence, and methods, not just flat citation links. It uses a 4 billion parameter information extraction model trained with reinforcement learning. The pipeline is designed so agents can query it natively, enabling multi-hop scientific reasoning that goes far beyond paper A cites paper B. And in the physical world, we have LabVLA, a vision language action model trained specifically for scientific laboratories. Its creators built a simulation engine called RoboGenesis that composes lab workflows from atomic skills like pipetting, measuring, and mixing, and then trained the model with a two-stage recipe that first makes it action-aware, then attaches a diffusion-based action expert. It handles transparent liquids, lab instruments, and fixed protocol workflows that standard household-trained VLA models cannot touch. Host. There is also EpiBench for epigenomics analysis, showing that even the best agents still top out at around 45% success on verifiable lab analysis tasks. And SupraBench for supramolecular chemistry, revealing that LLMs leave substantial headroom on domain-specific molecular reasoning. Taken together, these papers tell a coherent story. We've moved past the question of whether AI can participate in science. The question now is how to engineer the environments, knowledge bases, and physical interfaces that let it participate reliably. Host. Every few months in AI, a phase shift happens. Last quarter it was reasoning at inference time. This week, it's science as a full-stack AI problem, from reading literature to generating hypotheses to physically running experiments. EurekAgent showed it can discover novel results for pennies. Agents K1 mapped millions of papers into machine-readable knowledge. LabVLA put a robot at the lab bench. The bottleneck is no longer intelligence. It is environment engineering. And that is an engineering problem we know how to solve. This has been your Frontier AI Research Digest. See you next week. Papers referenced: EurekAgent, 2606.13662, Agents K1, 2006.